Good day, students. How are you doing? This is me again, Sir Nivero, and welcome to our YouTube channel. So for today, we're going to continue talking about quadratic functions. So in the last video that we had, we defined what is a quadratic function, and so for today, we're going to discuss about the other forms of quadratic function and how to transform a particular form of quadratic function to another. So before that, let's have a short review on the definition of a quadratic function. Right, so a polynomial of degree 0 is called a constant function, and a polynomial function of degree 1 is called a linear function. A degree 2 polynomial function is called a quadratic function that has a general form of p of x equal to ax squared plus bx plus c, or usually p of x, f of x, it's the same, doesn't matter. So where a, b, and c are real numbers, and a must be equal to 0. So p of x or f of x, it depends on the usage, of what function is being represented. So that is why in this form, if you're going to use f of x, it won't matter, but in the problems that we're going to use later, then it will matter. So quadratic functions are incredibly important, because that's what I've said in the discussions. It has a lot of applications, which is noticeable in the physical world, of course. So just like what I've said earlier, how to rewrite quadratic functions from this form, the general to the vertex or standard, and vice versa. So let's rewrite. So the standard form, this one, this is the standard form. So you might confuse the standard form of quadratic function to the standard form of quadratic equation. So they're different concepts. That means they have different different approaches, etc. concepts as well. So in this time, the standard form of a quadratic function is not the same with the quadratic equation, all right? But the general form of quadratic function is the same with the standard form of quadratic equation. So skip to those skip with those confusion, right? So the standard form is similar, or what we call also the vertex form, okay? So which has the form of p of x equal to a x minus h squared plus k. But question is, how did we arrive to that equation, to that function, to that representation, to that form? So where h and k is the vertex of each graph, and a must be equal to 0. So yeah, from the general form, no? So and then we try to group the terms containing the x variables, right? And then we factor out a, okay? So to factor out a, we need to divide every terms here by a, right? Next, after factoring out a, we added and subtracted the same, also b over 2a squared. So you might notice earlier that I won't be subtracting inside the parentheses, rather outside. But this and that time I will include a when I subtract it outside. Anyways, I will explain. So moving on. So here in the next line, I moved the negative b over 2a squared outside, but notice that the numerator is b squared because we already squared it, and for a squared supposedly. But since we have a here, so to explain that, if we try to get something outside the parentheses, you must also include this a, because like in the very beginning, diba, we need to multiply every terms here by a. So if you try to move it outside, basically you have to move it along with a. So basically it becomes negative a, then b squared over 4a squared. So what happened here is we cancel this one, this becomes 1 na lang. So negative b squared over 4a. Alright? So moving on, so that's what happened here. And so as to move further, we try to put this one into a square of binomial. So we use the square, the half of the middle term, right? So we have a quantity x plus b over 2a, then square minus b square over 4a plus c. But notice that these two here can be combined, and which can also be rearranged as c minus b square over 4a. So if we try to combine that together, that becomes what? So the LCD is 4a, so yeah, it's 4ac over b square. So if we try to write it in the vertex form, or this one, this will be the result. So a quantity x plus b over 2a square plus 4ac minus b square all over 4a, which means that our h is this one. Just take the negative, the opposite of that, and then this one, whatever the sign, just copy. Alright, so to summarize, this is our general form, and then if you're asked for the vertex, then you have this formula. So anyways, I will have an example of this later in the next following videos. And then to get the axis of symmetry, we have x equal to negative b over 2a. The standard form is this one. Alright. Okay, and then the vertex is h and hk. Then axis of symmetry is x equal to h. And h and k has the formula following. So for h, negative b over 2a, and then k for ac minus b square all over 4a. Now, if a here, whatever the value of a here, if a is positive, greater than 0, then it opens upward. The graph opens upward. But if a is less than 0, then the graph opens downward. But anyways, we're not going to talk about graphs today. We're going to talk about transformation. No, not transformation, but rewriting equations. Yeah. So rewrite the following quadratic functions in the form f of x equal to a quantity x minus h square plus k. So first example, we have using actually there are two methods on how to write this from the general to the standard form. So we first we use the completing the square. So the same examples will be used in the second method, alright? The first example we have here, x squared minus 2x minus 15. So for that, we have to group the terms containing the x variables. So there, we group it out. And then if there's an a here, you need to factor it out. Yeah, actually there's an a, but it's 1. So if you try to factor 1, anyway, it's still 1. So it won't change the fact that it's still 1. Okay? So to complete the square, we need to add and subtract the half of negative 2 and square it. So half of negative 2 is 1, negative 1, and then squared, it's positive 1. So if you noticed here, I added 1 inside but subtracted 1 outside because the a here is also 1. So it won't matter because 1 times 1 is just 1, right? So now we express it in the vertex form or standard form, because this one will be square of binomial, and then this one combine negative 15 minus 1, so negative 16. So all in all, the vertex form is f of x equal to quantity x minus 1 square minus 16, which gives us h, or h equal to 1. You just take the opposite sign of this, and the k is just copy whatever the sign is, negative 16. So again, if you take the h, the opposite sign, but the k, whatever the sign is. Now let's go to example number 2, 2x squared minus 7. So this time the linear term is not around, so you have to write it down. So group the terms containing x, then with the parenthesis, then factor out the 2. Alright, so to factor out the 2, you need to divide. Alright, and then to complete the square, you need to add the square of half of the middle term. So 0 divided by 2, it's 0, 0 squared, 0 gapon. So yeah, and then again, even if there's a here outside, yeah, 2 times 0 anyway, it's still 0. So I just simply subtracted 0 directly. So to put this into vertex form, so we need to write this one into a square of binomial. Of course, the second term is, the last term is 0, so x minus 2 quantity x minus 0 square minus 7. So this is already the standard form, which gives us the h as 0 and k is -7. Now let's go to number 3. So in number 3 example is not yet written in this form, ax squared plus bx plus c, so that is why we have to rewrite it. After rewriting it in the form ax squared plus bx plus c, we group the terms containing x and then factor out -3. So yeah, factor out -3, we need to divide both terms by -3. Alright, and then yeah, the remaining ones are this x squared minus 1/3 x plus 4. Then you complete the square by adding -1/6 square. So 1/6 square, that's basically 1/36, right? So now notice that diba 4 na lang to. So and then there's a 3 here. So why is it that there's a 3 here? Because the a is -3. -3 I mean. So, diba, subtraction man na siya. Then, pag square ani, becomes positive. So, -3 times 1/36, which can also be cancelled. Negative times negative, it becomes positive. And then this one, biging 12 na yan. So, yeah. Then, express into square of binomial. There. And then, f of x equal to -3x minus 1/6 because, diba, mamaya siya itong gamit, -1/6 square plus, if you add 4 plus 1/12, that is 49/12, which gives us an h 1/6 and k is 49/12. So last example, 4x squared plus 5x. So this one is just so easy. Divide both terms by 4 to factor out the a. No? And then how do we get this 5/8 square? So half of 5/4 is 5/8, and then you square it. That's it. So now, since our a is greater than 1, so 4, if we try to move this minus outside, then it becomes -4 25/64. So we have to square it. Then square na siya. Pag square, cancel na siya. This becomes 16. Alright? So express this term here, this part here as square of binomial. Then, yeah. 4 quantity x plus 5/8 square minus 25/16, which gives us an h equal to -5/8 and k equal to -25/16. So again, take the opposite side of this. So now let's proceed using the formula. Okay, so yeah, so the same equations, the same functions will be used in this example. So for number 1, x squared minus 2x minus 15. So substitute the values of a, b, and c. So the value of a is 1, b is -2, c is -15. So the formula for h is -b/2a equal to negative. So b here is -2, then 2 is 2 times a, which is 1. So, negative times negative, that's positive na. Then, 2 times 1 is just 2. So, 2/2 is equal to 1. And then, 4ac minus b squared all over 4a. So, 4 times 1 times -15 minus the -2 square all over 4 times 1. So, -15 times 4 is -60 minus 4. -64 over 4 is -16. Check. Then, after obtaining h equal to 1 and k is equal to -16, we simply substitute it here, including a. So, a is 1, so no need to write. 1 is yeah. Substitute it to the vertex form. And k is equal to -16. So, x minus 1 square minus 16. Okay, I'll just have the other examples to the part 2 of this video. Thank you and God bless.